Let's have a look at Federated ID and with a special focus on the OAuth and OAuth 2. At the present time we have so many systems that we log into: our bank systems, our social networking, our email, our healthcare records, our blogging, and lots of other systems that we have logins for. It's becoming more and more difficult to keep track of all these different logins, and along with this often we only have a few passwords, so it's not that it's any more secure that we use lots of different logins and IDs. So perhaps in the future what we'll have is what's called trust infrastructures. With this we might trust one identity provider to identify ourselves, and then as long as that is trusted by the systems that we actually use, then we can use that identity provider to be able to provide the application with our identity, and then thus gain rights onto it. Any given time the system may be compromised and we might not trust a certain provider anymore, but the whole thing becomes much more dynamic. Identity is becoming a key part of our online presence, and it's obviously important that we have some control over our identity. And there are many ways that we can identify ourselves, such as digital certificates, to identify users and devices and so on. And unfortunately the system we've created around digital certificates isn't really well developed enough in terms of the understanding from users about what a digital certificate is. What's meant to happen is when we access a remote server, we get a certificate back. We're meant to check the server for its details and then who it's actually signed by. But unfortunately most users don't actually do this. So the whole method of digital certificates, or the PKI infrastructure, really doesn't work that well. The future is likely to be that we can actually select or manage our own identity, and then define how that identity is actually used. So we might have an identity store, and then the details within the identity store, we could actually provide certain users or certain applications access to parts of our identity. But the good thing about it is that it has one place where we can actually store our identity, and then we can define the rights of how it's actually going to be used. Most of the systems we've actually created, our identity is stored on other systems, and the access to that may actually be breaching many laws and regulations. So the normal way that we would identify someone is with something that you know, something you are, something you have, and somewhere you are. Something you know is something like a password, a username and password. Something you are is maybe the colour of your eyes. Something you have could be a credit card, and somewhere you are is obviously your location. So something like a SIM card identifies a user, and it's something that they have. A fingerprint again is something that you have. Shopping Morningside is somewhere you are. Username and password is something you know. You own a digital certificate is something you have. You can remember your mother's maiden name is something you know. And so on. Okay, in this way we can actually identify a user. Often in highly secure systems we want more than one or multi-factor authentication, where it's not just something that you know, such as username and password, but it might be other things such as where you actually are. So the systems we've created are often isolated and really don't integrate with each other. So a key factor in the future is of the web is our trust infrastructure, where certain organizations and applications can trust other applications and organizations. And this gives us what's called a federated identity management infrastructure. And really it gives us a good model of what the internet could end up with. The user goes and asks for a certain service from the web. The web application then tells the user what's required, what identity providers are actually trusted, and what attributes are required to be able to consume the service. The user can then select which identity provider they prefer, such as in this case it could be Windows Live. They will then get a ticket from there. They give the ticket to the service checks the ticket to see if it was identified by the user. It was signed by the identity provider. If it was, then they will get rights and a service can be invoked in the cloud. One initiative which is growing in its scope is OpenID. And with OpenID we can actually define our identity and then we can manage it. Our identity can then be released, or attributes around their identity can be released to certain applications that are required. So OpenID has now spun into the OAuth, and especially into OAuth 2, and many companies now support OAuth in terms of their identity provision. And really it's fairly simple in its scope. Basically we have what's called the relying party, and this is really the service that we're trying to access, and then we have our identity provider, and there must be some binding of trust between the identity provider and the service provider. So basically we will go, if we were going on a flight, we'd check in to our identity provider, show our identity and get a token. We then go and take the token to the airline security in this case, which is the relying party, and as long as they trust each other, then we don't have to show our passport again. As long as the ticket has been granted, then the relying party trusts the identity provider. Then we can have a federated infrastructure where we could have several identity check-ins here, and each can allocate a ticket that's trusted, and this will give us our federated structure. The basic use case is this. The user logs on and accesses a service. The service then tells the user what identity provision is required. The user then selects one of their identity providers that is within the trusted network. They then prove their identity, such as logging in, and they will get a token based on this, and that's a claims token to their identity. That's then passed to the relying party. Relying party reads it and is able to determine that it has been signed by the identity provider. Good thing here is there's no communication between the identity provider and the relying party. Okay, so let's look at an example of this using OAuth. In this case we're using OAuth and we're using ASP-MVC4 to be able to integrate. So in this way we're going to actually log in to the identity providers, and then we're going to pull off some information from each of the identity providers, and that could provide us with a basic login. So in this case I'm going to log in through Twitter. We can see here this is it's managed to get my name and then basic user ID from Twitter. So now I'll try Facebook, and it's already pre-cached here. Again, it's managed to get my name from Facebook and a unique ID. We'll try Google. So it's already remembered my login here. And so I'm allowing it to be able to log me in for this once, but I could obviously allow it to be logged in for many sort of logins, and that's a one-time password type system. In this case it's managed to get my email address with Google. And then finally we have Microsoft here. So you see it goes to the website and then it will come back and we can get the username. So in this way we can actually create trusted infrastructures. As another example, these are a number of identity providers here. We can use OpenID, and with OpenID we get a string or a URL to identify ourselves. Rather than a username and password. And then once we go here, then we can actually sign in. And this way we could have our identity stored here. Okay, so in here I could trust this site again when I log in, but I'll continue. Okay, so in that way I've managed to log in, and we can do it with WordPress and so on. Okay, so let's look at the code. So ASP.NET MVC4 allows us to very simply connect to OAuth 2. This is our main web page here. This is where we're showing our identity providers and then displaying the results here. If you look at our controller, then our controller has a number of methods which are called to be able to process it. So we just find the main. So here is our main connection to the. This is where we register our clients within OAuth.config.cs. We register a number of clients, and then when we call up the web page that we've seen earlier, this then registers the clients, which are actually shown here. So for every one it will show a little button and so on. Then when we click on a button, it will call up external login here. And let's try and find that. Here we go. That then requests an authentication from the provider. So the provider is actually passed into here from the web page. It will then do a request to it. Then it does a callback. So the callback is whenever the request comes back again after it's been logged in successfully or unsuccessfully, it will go back to here with a callback. It then determines the result of the callback, pulls it back again. If it's not successful, then it won't really do anything and call the web page back again. But if it is, we can actually pull back the login data, and this is in the form of a JSON string. We can then pick off from that the details from the account. So Facebook will give us an ID, name, link, gender, access token, birthday, and so on. LinkedIn gives us these parameters that we can read off from the JSON string. Twitter gives us these, and Microsoft gives us these ones. We can then go to each, get the result, and these are the extra data, and we can actually pull off the details, which we then just use the view data to be able to view the details. Within the auth config, we define our basic registration details for each of the clients that we're going to connect to. So this is generated from an API key generator that we get from the identity provider. Okay, and that's provided a basic introduction to OAuth and federated identity.